Welcome to the deep dive. We're cutting straight through the noise today.
Yep.
We're looking at something pretty innovative, maybe kind of complex, in the data center space. The HPE Aruba CX 10,000 switch, specifically with that integrated Pensando DPU.
hmm
Now, look, this isn't about passing some exam, okay? This is about getting a real shortcut to understanding how these distributed services and zero trust security are actually being built into the network fabric now.
That's exactly right. The sources we're looking at, they're super focused, really defining the cutting edge in network automation services distribution.
Right.
So we're going to dive into the roles of like three key pieces.
Yep.
The DPU itself, that's the distributed processor, the policy services manager, or PSM, and the fabric composer, HFC.
Okay.
If you get how these three interact,
Yeah.
you basically get where secure networking is headed.
All right, let's unpack that. Let's jump right into the architecture, though.
So when we talk about the CX-10000, you're really looking at a switch that acts like two things working together perfectly synced up. First, you've got the core network switch part running the Aruba SCX network operating system.
Yeah.
That handles your standard layer 2, layer 3 fabric stuff.
The usual network brain.
Exactly. But the second bit, the really transformative part, is that integrated Pensando P4 DPU, the distributed services processor.
Okay, so network brain and services brain. What's the real deal, then, with having that DPU physically in the switch? Why not just use the main switch CPU like always?
Well, the DPU, that's the breakthrough, because it offloads stateful services.
Okay, like.
Think about your traditional firewalls, network address translation, even telemetry gathering. If the main switch CPU, or worse, the server CPU tries to handle all that, performance goes all over the place. It gets unpredictable.
Yeah, I can see that.
So by pushing these services onto this dedicated DPU, you get predictable like wire speed latency for all that security processing. You're saving server cycles and making sure security gets applied super fast right there in the fabric.
Okay, that makes the value proposition clear. Predictable speed for security. Got it. Now, management. This is where my head starts to spin a bit. You've got two big acronyms, HPE Aruba Networking Fabric Composer, HFC, and the Pensando Policy Services Manager, PSM. They both manage stuff. How do we keep their roles straight?
Yeah, good question. Let's try an analogy. Maybe that'll help lock it in.
Yeah.
Think of HFC as like the Department of Transportation.
Okay.
Its job, build and orchestrate the network fabric,
Mm-hmm.
the roads, the bridges,
Yeah.
the underlay, the overlay connectivity. It automates setting up that whole spine leaf topology.
Right. The infrastructure builder.
And the PSM.
The PSM. That's more like a
Yeah.
highway patrol.
Yeah.
Its job is to manage the distributed stateful services. The security policies running on those roads HFC built. This is where you actually configure every single zero trust firewall rule, every NAT policy. HFC builds the roads. PSM sets up security checkpoints basically on every lane. They're handling completely different things. Okay, that analogy clicks. Yeah. Department of Transport, Highway Patrol, builds connectivity versus enforces policy. Got it. Now, a really practical point for anyone actually deploying this stuff. The PSM, it's often a VM, right?
Yep, usually deployed as a VM, yeah.
So why can't we just lean on standard virtualization stuff like, I don't know, VMware fault tolerance for high availability? Why do the docs insist on this dedicated cluster thing?
That's a really good point to raise. See, standard VMware FT makes sure the VM itself is redundant, right?
Yeah.
If one host dies, the VM keeps running.
Yeah.
But it doesn't guarantee the consistency and availability of the actual policy database that the PSM is managing across potentially multiple switches or locations.
Okay. The data inside.
Exactly. To keep that policy state totally consistent everywhere and to get real cluster-level resilience, for production, you absolutely must deploy 3-node PSM clusters.
3 nodes. Why 3?
That's what you need to establish quorum. It prevents any weird split-brain situations where different parts of your network might get conflicting policies if there's a partition. Without that 3-node setup, honestly, your policy plane is just too vulnerable for production.
Okay, so the security brain, the PSM, needs that 3-node quorum to be stable.
Right.
Now let's look at the nervous system it's controlling, the actual wires, the connections that Fabric Composer HFC manages. When HFC builds that big spine leaf setup, what are the two main protocols it uses for the underlay and the overlay?
Yeah, this is pretty standard for modern spine leaf now.
Yeah.
For the L3 underlay, that's just handling the basic IP routing between all the switches, getting packets from A to B HSC, automates setting up BGP.
BGP.
Border Gateway Protocol.
Yeah.
Super robust, scales really well for routing between devices. Then for the L2, L3 overlay, that's where you create your actual virtual networks.
Mm-hmm.
The segmentation uses EVPN VXLAN.
EVPN VXLAN.
Yeah, Ethernet VPN with VXLAN encapsulation. Fabric Composer uses both together, BGP underneath and EVPN VXLAN on top, to create that whole integrated automated fabric.
Okay, but hold on. We've used VLANs for ages, right? Why is VXLAN suddenly necessary here? What's the big problem that EVPN VXLAN solves that, plain old layer 2 couldn't handle in these huge, maybe multi-tenant data centers?
Scalability and multi-tenancy, plain and simple.
How so?
Well, traditional VLANs, you're limited to, 4096 segments, the 12-bit ID.
Yeah, 4094 usable, something like that.
Right, which sounds like a lot, but in a big cloud environment or even a large enterprise needing serious separation between departments or tenants, it's just not enough anymore. You run out.
Okay.
VXLAN completely blows that away. It uses a 24-bit identifier, the VNI VXLAN network identifier. That gives you like 16 million possible network segments.
Whoa, okay. 16 million versus 4,000. Big difference.
Huge difference. And then EVPN, that's the control plane part. It makes sure everything operates without loops, and it handles distributing all the MC address and IP route information efficiently across that underlying BGP network. HFC basically needs VXLAN to handle virtualization and segmentation at the scale we see today.
Gotcha. So BGP routes the physical gear, the underlay, and EVPN VXLAN handles potentially millions of virtual scalable networks on top. Makes sense for these massive environments.
And this whole infrastructure conversation leads us right back to the DPU's, frankly, killer app.
Yeah.
Doing zero trust security, especially for all that east-west traffic.
Exactly. That server-to-server traffic inside the data center.
So, okay, we established PSM manages the firewall policies, but where does the actual enforcement happen? We know it's not way up at the spine switch.
Okay.
Is it, on the server itself somehow?
Nope. And that's the key advantage here. Enforcement happens directly at the Pensando DPU, which sits right there in the leaf switch. Specifically, it happens as traffic is coming into or going out of the server-facing port on that switch.
Right at the port connecting to the server.
It's right there. That's the moment of truth for every packet.
Yeah.
Because the DPU's right there, the policy gets applied per flow, per tenant, super close to the actual workload.
And that proximity, it means you don't need to drag traffic all the way over to some centralized firewall appliance and back again. That whole hairpinning thing. It cuts latency way down and maximizes security coverage.
Right, that granular control right at the port. That's what enables this microsegmentation thing everyone talks about, isn't it? Before we define it, though, let's just think about the old way. Traditionally, if two servers were plugged into the same switch, same VLAN, they could pretty much just talk freely, right? No checks between them.
Absolutely. That was the classic perimeter defense model. Hard shell, soft, chewy center. It kind of assumed internal traffic was trusted.
Yeah.
Once an attacker got past the main firewall, if they landed on one server, they could often move sideways laterally to other servers on the same network segment pretty easily.
Yeah, that lateral movement problem. Okay, so given that context, how would you define the main idea behind microsegmentation, especially how this CX-10000 architecture does it?
Microsegmentation, in this context, lets you enforce granular zero-trust policies between individual workloads, even if those workloads are sitting on the exact same VLAN or the same IP subnet.
Even on the same virtual wire, basically.
Exactly. It treats every single connection attempt as potentially untrusted, potentially hostile. You're essentially pushing the firewall enforcement point from the big data center edge right down to the virtual network interface of each individual application or server.
Okay, let's shift gears slightly to automation. One of the big benefits the sources keep highlighting is how Fabric Composer integrates with the virtualization layer, specifically VMware vCenter. What's the #1 automation win that integration gives an organization that's maybe struggling with, like configuration drift?
Oh, it's huge for operations teams. The beauty of that integration is HFC actively listens to vCenter. So the primary benefit is that HFC automatically provisions the necessary network segments, the VLANs or the VXLAN VNIs, to perfectly match the vSphere port groups that the server admins create.
So a server team makes a port group.
And HFC instantly creates the corresponding network plumbing on the Fabric side. Automatically.
So it stops that whole mess where the server team sets up a port group for an app, and then the network team has to manually configure the switch ports, and maybe they get it slightly wrong or forget.
Precisely. It eliminates that configuration drift, keeps the network and the virtualization environment constantly, perpetually aligned. That's a massive operational headache removed right there.
Yeah, no kidding. Eliminating config drift.
Yeah.
Huge win. Okay, now visibility. You mentioned earlier the DPU is a powerhouse for telemetry. Why is the fact that the CX-10000 DPU gives 100% full fidelity visibility. Why is that such a game changer? Especially maybe for security audits or troubleshooting tricky problems.
It changes everything because of that no sampling aspect. Think about older methods like NetFlow or maybe SFlow. They generally sample the traffic, right?
Yeah, like 1 in every 1,000 packets or something.
Exactly. It's like having a security camera that only takes a picture every, say, 5 minutes. You might completely miss the actual break-in, the important event. The DPU, because it's processing everything anyway for security, it records details for every single monitored flow. No sampling. It's like having a continuous full-res security video of all your east-west traffic.
Wow.
That depth of data, I mean, for doing forensic analysis after an incident or just proving compliance for an audit, it's indispensable. You know exactly what, talk to what, when, and how much.
Unsampled data. Okay, that completely changes the audit trail. Now, practical question. If an admin actually wants to collect and view those critical firewall policy logs that the DPU is generating, what 2 essential steps do they have to take within this whole PSM DPU ecosystem?
Right. Yeah, it's not quite automatic out of the box. It's a 2-part process. First, inside the Pensando PSM, where you define the firewall rules. You have to explicitly enable logging on the specific rules you care about.
Turn it on per rule.
Yep, they don't log by default, probably to save resources. Second, once logging is enabled on the rule, you then have to configure the DPU itself to stream those logs somewhere useful. Like say to an external collector, maybe a centralized syslog server or an IPFAX collector or some Zeem tool.
Gotcha. So enable on the rule in PSM, then point the DPU's logs somewhere off box.
Exactly. If you forget that second step, the logs might get generated on the switch temporarily, but they won't be stored anywhere long-term or be easily searchable. You got to do both to make the logs truly actionable.
Makes sense. Okay, finally, operational safety. We've got this really powerful fabric composer, HFC, controlling the entire network fabric automatically. What if you have, say, a junior administrator, someone who needs read-only access, maybe just to view the network topology, see the automation status, but you absolutely cannot risk them accidentally changing anything? How do you manage that safely?
Yeah, that's super important with this level of automation. You absolutely use role-based access control, or RBAC. And critically, you don't just give them a standard admin role. You must create a custom RBAC role, specifically designed with strict read-only permissions. Limit their view to only the things they need to see, like the topology view or status dashboards, and ensure they have 0 configuration rights.
So a custom view-only role is essential.
Essential. It's all about separation of duties. Because HFC does so much automatically, giving someone view-only access via a carefully crafted custom role lets them help with troubleshooting and maintain visibility, without any risk of them causing an outage through an accidental click or misunderstanding.
We hope this deep dive into the CX10000 architecture gave you the full picture at high speed. If you want to explore more, definitely start digging into BGP, EVPN, VXLAN, and maybe that whole concept of eliminating config drift with unified automation. Some really powerful ideas there. Until next time, stay curious.